Displacement versus time. Kinematics equation 1 allows us to determine the velocity of an object undergoing constant acceleration at any given time. We will now develop equations to determine the displacement of an object undergoing constant acceleration at any given time. This approach will depend on two different but consistent ways of determining average velocity. We already learned that average velocity is given by change in position over change in time. This simply says that the average velocity of an object over an elapsed time, delta t, is given by its displacement divided by that elapsed time. This is always true. Even though this course is limited to cases of constant acceleration, the above equation is true even if acceleration is not constant. To find the displacement of an object traveling at that average velocity over a given time, we can solve this equation for delta x, displacement. So multiply both sides by delta t and flip it around, and we get displacement equals average velocity times the change in time. This says that the displacement of an object is just its average velocity times the amount of time it has traveled at that velocity. Using this equation requires we first find the average velocity. We can find the average velocity of an object moving at a constant acceleration by just averaging its initial and final velocities, the same way you would find the average of any two numbers. So we have final velocity plus initial velocity divided by 2. So imagine you want to find the average of 4 and 8. You would add them together and divide by the number of numbers, right? So that would be 12 divided by 2, which is 6. Yes, this works. This is just finding the average of any two numbers. This works in this course since we will not address cases of changing acceleration. This method will not work in some calculus-based physics problems in APC. This equation states that the average velocity of an object over an elapsed time, delta t, is the sum of its initial velocity and final velocity divided by 2. You can solve a wide variety of problems with these two equations. First, you can find the average velocity of an object with this equation. Then you can find its displacement by using this equation. These two equations can be combined to skip the middle step of determining the average velocity before determining the displacement over time. Just set them equal to one another, solve for delta x, and finally assume that our initial time is 0. So delta t just becomes t, and we set this equal to this right here. And then we're going to multiply delta t over to the other side, and then we have this new equation. This is a kinematics equation, but it's not one of the ones listed on the AP Physics 1 equation sheet. We're just going to use this to derive the second kinematics equation. An object constantly accelerates from rest to 5 meters per second in 8 seconds. What was its average velocity and how far did it travel? Alright, so first we write out our givens. This object accelerates from rest, which means the initial velocity is 0. The final velocity is 5 meters per second. The initial time is 0, and the final time is 8 seconds. So first, we're going to find our average velocity. We're just going to average the velocities, initial and final. And we get that our average velocity is 2.5 meters per second. Finally, we're going to plug it into this equation, figure out how far we traveled. So our average velocity was 2.5. Our time span was 8 seconds, therefore we traveled for 20 meters.